Welcome, everyone. So how many folks went to the overview this morning? Everybody? All right, we have, so everybody got their ability to, or their entry form for the drone. If anybody didn't get one, we have a few more here. I'll just reiterate, the Phantom 3 is pretty cool. I got one. So thanks. Again, I will apologize in advance. I have been going through coughing fits for the last little bit here, so if I pause for a little bit, turn the mic off, and start hacking up along up here, you know, just try and avoid it laying on the floor. So again, my name is Richelle Ahlvers. I'm with Broadcom Limited. I'm a principal storage management architect. I have to do my own introduction this time. How plebeian. I'm also the chair of the Scalable Storage Management TWG, which is the technical work group that has been producing the Swordfish specification. We would encourage any and all of you to join our work. So again, just a little bit of what we're going to cover in here. Sorry. Our crazy little, well, what we're going to cover in here today is a little bit more detail on, and a deep dive in a little bit more detail than we covered this morning on what Swordfish looks like. You know, what's in the spec, what's in the bundle that we've released, what's the work look like, a little bit more into the schemas, and I apologize for this fun little, you know, it's kind of for our fun little display here, Dawn, I don't know if there's anything else we can do about this, but this is kind of blipping in and out here, so I'm not sure there's anything else we can do about it. But hopefully this will kind of stay up for us. Anyway, so we'll be diving into this in more detail. Okay, so again, Redfish or Swordfish builds on Redfish. Built on formatting using RESTful API that uses JSON and OData, and we'll, again, show more details about that. Okay, again, the major bullet item on the disclaimer slide is stuff's changing. This is a snapshot of where we are currently. If you want more details, remember SNIA.org/swordfish. Well, now my screen's blanking out, too. This is awesome. Since everybody in here heard me do the entire spiel about what it is, I can skip this one, right? Yeah, okay. Some of these are duplicates because I wasn't sure how much overlap we'd have, or if we'd have folks in here that hadn't heard all of this, so there's some filler in here for that. And so one of the things I will do is I want to point out some of the folks in here in this smaller forum that have actually been actively working on the spec. So we've got a handful of folks in here that I will probably point to at various points. So we have Hector in the back from Microsoft, who's been very active in helping to drive things from the client perspective. Got Don Deal over here, who's my co-chair from NetApp. And there's Patrick, and Patrick from Dell. Dell is not just contributing to Swordfish, he's our Redfish liaison as well. So he's the guy that's actually helping us get everything brought into Swordfish from the Redfish perspective. So that's also a little bit of not only the companies, but also some of the folks working on things from some different perspectives. We talked about this a little bit. What are we including in from the 1.0, and I skimmed this a little bit this morning, and we'll go into this in a little bit more detail. I'd like to highlight just one thing on here. The file system storage leverages all of the block infrastructure. There are literally 2 schemas that we add specifically for file systems. Everything else sits directly on top of block. We add 2 schemas for a file. That was the way we're going to do that. We expect when we go to do object, we'll be able to do exactly the same thing. So We expect to be able to add class of service capabilities. I'm sorry, this is really it's both frustrating and entertaining. We'll be able to add object in a very similar fashion. We want to extend it to class of service the same way. So object drive, I talked about what this was this morning, but not how we did it. Object drives we've actually added by adding just extending Redfish very simplistic, very seamlessly. We've added an additional attribute in chassis and Redfish. So it's actually not something we added on the Swordfish side. We actually extended Redfish in the SPMF side to add an additional attribute in the chassis type field. So you won't even see object drive specifically in Swordfish. We actually added it in the Redfish side. That's how tight our collaboration is. Okay, so we looked at this morning. Again, so I'm not going to spend any time on that slide. These slides we've already looked at, so let's move on ahead. So what do we actually include in the bundle in our V1 release? We included the technical spec. So the spec includes all of the normative requirements for the storage implementations. It does not include any of the Redfish underlying protocol specs. Implementers, users, anybody who needs that level of detail, you actually just go look at the Redfish spec. What we did was in this document, we focused exclusively on all the Swordfish content. There was really no reason for us to try and duplicate it. We did, in a few parts, reference things. We tightened up the spec in a few spots from what Redfish required. An example of that, security. The Redfish spec basically said things like, if you do HTTPS, use this level, and we basically said, use HTTPS in your implementation, right? It's not optional. If you're doing a Swordfish implementation, it's going to be secure. So there's a few things like that in the spec, but for the most part, we're like, they do the protocol. We're not going to focus on that. We're going to focus on the functionality, and that's what you'll see in our spec. We also didn't include any of the referenced schema from Redfish. It's all in their documentation. We talk a little bit about where we extend it, but for the most part, we didn't feel the need to duplicate any of that information. We also started with a user's guide. Now, historically, folks have in standard spaces and in SNIA have started with focusing on things that the vendors and implementers used. One of the things we've really done differently here has been focusing from a client side. We kept sliding into that a lot and had to back ourselves out and say, no, client view, user view. And so what we really did was we focused on 3 perspectives from and 3 roles, 3 actors, a storage admin, a cloud admin, and a DevOps. And we put them into 4 management domains. We expect this to grow. So we have basically what we call a service catalog domain, a block services domain, a file services domain, and I forgot the 4th one off the top of my head. I have to go look it up. But basically, and we expect that to grow. We expect to see more things in there. We released with basically 12-ish use cases in there, and we will expand that. Like we said, we did this in 9 months. We focused on the spec first, and we started putting the user's guide together in the last few months. And this whole thing is designed to just be easily expandable. So when we have people come to us and say, can you add this use case? Our answer will most likely be, yes, we can. And so we write it up and we add it in. And so that's the way we have designed this document to work. And the other couple of major pieces are the schema. Schema is very important. All the documentation and information about the schema has been extracted and put into the spec. So we actually have tools that do that for us automatically. We curse them because they don't work perfectly. But the primary work we do is to define the schema. They come in two formats. They come in two flavors, and we'll talk through and show you examples of those here in a little bit. The CSDL or XML schema or JSON, whichever your preference is. We actually end up doing most of our primary work in the XML format, and then have tools that convert them to produce the JSON schema. Those contain, and I have examples before I jump into that. The mockups we talked about this morning as well. Yes.
Just wanted to understand how does it fit with OpenStack?
Right now it's an independent effort, but what we expect to do with OpenStack is work in a couple of different areas. So we expect that we will build a Swordfish driver that integrates with Cinder. So Redfish has already built a Redfish driver that integrates with Ironic. And so we expect to see a parallel effort to be able to do that, REST to REST. We've also talked about building and have been looking at building a OpenStack client, open source client framework, maybe potentially in partnership with the Open Linux Foundation, that would be basically a framework that could integrate with multiple frameworks, including OpenStack. So some of those are all discussions that are in the works.
So is there anything more that this provides than what Cinder module has, or is it?
Effectively, yes, because this is going to be a complete management model for storage devices. And Cinder is focused on a subset of functionality for integrating specifically with OpenStack. Today we have basically, I think a subset of the functionality we'll eventually get to, and we've got some stuff to add. But right now, we're probably still even a superset of what Cinder has. Go ahead, Hector. Yeah.
Consuming Swordfish in an OpenStack environment, so the Cinder driver, and then exposing Swordfish on the northbound of OpenStack if you wanted to automate file share provisioning, provisioning. So it just depends on which party you want to integrate. If you're consuming Swordfish from the bottom or exposing Swordfish from the top.
Right. Okay, and the mockups, which we saw a little bit of this morning, but we'll show in both a couple of sources that you can get to play with yourself. I talked about those this morning, and we'll look at it in a little bit more detail. We also include documentation. I mentioned this again as well, documentation to help with usage. I also showed that one. So jumping into the mockups a little bit, this is going to be a little bit difficult. You guys can't see that. So we talked a little bit already this morning about the overview of the mockups and how to navigate through that. And we covered all of those. And I inadvertently this morning said, I'm going to show you more detail about that, forgetting it was in this slide set instead of the one this morning. But looking at more detail at class of service. So we talked a little bit already about classes of service being a really key concept here. Classes of service are actually a construct that are defined. The way we structure this is they're defined from lines of service that are constructed from line of service capabilities. So what I wanted to do here was use this as an opportunity to jump in and show a couple of different ways that we have things represented here. And so I'm going to show you where these things are, both in the hierarchy, and use this as an example to show you some of the details around class of service. So there's two different places that I've mentioned that you can go look at examples of this, one of which is download the mockups and look at them yourself, or you can go to swordfish.mockable.io and look at them. So I have both of those open to show you. So here what I've done is I've actually loaded up just in Nginx, the local web server on my system, which I can't load. If we give myself a second. Oh, we don't have time for that. So what we can do basically, when we do that, I'm basically just referencing this off of the same kind of thing we've seen in the hierarchy here, off of my local web server /redfish/IO. Here's the service route. And these are to be the same mockups you'd see. So I'm just going to navigate down eventually.
So like authentication and views and isolation based on role and things like that, will people get to see, is it filtered anyway based on your role? How these elements are protected?
Right. So just for video perspective, or I think that does it pick these up very well. The question is really how do authentication and roles factor in? We're picking these up right now from the base infrastructure in Redfish, and we have plans to extend those jointly. Right now, there's basically 3 roles in place. There's administrator, operator, and read-only. And so you can configure those. We expect to expand them in the future to add some storage-specific roles, storage administrator and things as needed. But right now, you can map them over. The administrator is everything. Operator basically doesn't have permission to configure roles and doesn't have permission to configure the manager. And then read-only is read-only. So there's some protection in place, and we expect to be able to expand that. You can also as an implementation the implementers can add any additional roles they choose to.
But you can't filter based on agent or like certain services or this plugin and other services. Or if you have multiple plugins, you can't create isolation between them or anything like that.
What do you?
There's not in the standard, but there's nothing pretty good behind that.
Okay.
Yeah. So. Thanks, Patrick. All right, so I've gone down here. I got this a little bit big. I've gone down here into the storage service. Storage service 1 here is what we call our large mockup. This is kind of the big one that's got everything in it. So down in here, you can actually see here's a whole bunch of different classes of service that are defined. And we also have down at the bottom in the links, here are a whole set of line of service capabilities that are actually defined associated with this system. So if we go down and look at, say, here are a bunch of different kinds of capabilities. There's the data protection line of service capabilities, data security, data storage, I/O connectivity, and performance. So for each one of these, for each one of the classes of service, sorry for the scrolling, you can actually go in and define basically what properties related to each of those capabilities. Or you define lines of service, I should say, you define lines of service associated with each of those capabilities. So I forgot to type the classes of service. There are some tools that will allow you to treat all of these as hot links, and I just have a tendency to work this way because it's a little easier for me to blow things up full screen, and sometimes I mistype. Okay, so for this one, for example, what's actually configured here is these are the lines of service for this particular class of service. And again, this can be, the vendors can do this out of the box, or the storage admin can configure that. So this storage admin is configured this gold class of service in Boston with these a line of service that says, here's the I/O connectivity line of service, the performance, no particular attributes for the data protection. Security must be mapped to media encryption strength channel, this level of user authentication and host authentication, no requirements around antivirus. The data storage must be thin provisioned and must be space efficient, right? So those are a bunch of the attributes that this particular, and the ID of Gold Boston is, again, assigned by the storage administrator. And that's so that whoever is configuring it will know what that means, right? So that's kind of how the configuration of the class of service works, right? So then because this is REST-based, the queries to go find this in the system are standard. The user, DevOps or whoever, it could be the storage admin as well, can kind of go through and query to figure out whether it's script-based or just even in the web browser, can go through and query to go look at anything with this class of service, whether it's a storage pool, whether it's a volume, whatever's allocated for this class of service.
So which parts are part of the standard itself, the proposed standard, and parts that are?
All of this is actually part of the standard. So there are in every schema, there's an ability to add an OEM extension. That's just everything inherits from what we call the resource schema, which is we get from Redfish. And so every single one of these can add OEM extensions, but everything you're looking at here is part of the base standard. So there's opportunities everywhere for vendors to add differentiation, but this is all standard. Okay, and if you guys just want to go look at all of this stuff on, without installing everything, we have a lot of it instantiated again at swordfish.mockable.io. Here's just another tool we have. If you want to look at it in one that's clickable, sorry, let me collapse this down. You can go to swordfish.mockable.io, and you can. Why are you misbehaving? Really? All right. I don't know why that one's not working. It's working just. Yeah, I can. Oh, that's why it's not working. There we go. So, and again, you can see the same thing here. We just have a lot of this instantiated online. So we have this whole thing up here, so you can just go directly to this site and look at it too. So one of the things, let's see, where is it? It's under one of the cute little things we have up here, and we'll add more of these as we go, under storage services. Simple. Under storage pools, right? To get an idea of what you might see from a real system is here I'm down in this pool, and some of the attributes you can see here is capacity. Well, as you can see, just doing multiple gets, the capacity is increasing. So if I actually dug around in the attributes of this system, I'd see this. Eventually what you'd see is that this is actually, if I wandered around, you'd see this is actually a thinly provisioned system. So what this is corresponding to is just the increase in consumption of the system. So what Hector's actually done is, and he has this available on a blog post at Technet. It just went up today. He's got some PowerShell scripts and I'm blanking on the word, and yeah, the dashboard. Yep, and a dashboard that sits on top of this that actually shows some examples of how you can script right on top of this stuff. And it uses this mockable site as well as this capacity, this little capacity counter to show, to give some examples of how to use this API. So anything else you want to add to that, or?
Well, obviously, so what I have on Technet is a very PowerShell client focused. And so what we're trying to do here is make sure that clients get exposed to this, because there's a lot of great stuff here. For class of service, probably the most important that clients will need to consume and get used to. But at least for now, we can give them a nice primer to see past, there used to be something like System Center that had to interpret SMI-S and SMI-S to then create PowerShell. So now you can just use PowerShell directly. So for at least for the Microsoft user base, this is actually very, very powerful.
All right, so that's probably enough on all the mockups, and let's switch over a little bit to the schema. How are we actually defining all of these things? I think that was next in the slides, if I recall correctly. Yep. So there's really, again, there's two types of schema, CSDL and JSON. So these include constraints that not only annotate the REST API, or the REST information, but they annotate all the OData information for all the OData clients. So OData is a open industry standard developed by Oasis. So again, all of the .NET infrastructure and even a lot of the Microsoft tools and other things can actually read and consume OData metadata directly. So there's a couple of examples in here, and then I will actually bring them up a little bit bigger and we can take a look at them. So here are, I brought up, what do I have? Storage pool. So we're going to look at storage pool in a little bit of detail. I just picked up the same one so you can see the same schema in both the XML and then once it's converted to JSON. So the schema are set up in a few different sections. The top section is really import information, right? So all of these import sections up at the top here. This is just importing a bunch of dependencies, and then we come down into the actual. I kind of have this kind of bag, don't I? This is what happens when I'm half blind and looking at it on a tiny screen. You guys get a really big version of it. So this is actually you basically get the initial definition up starting at about here, where the element itself is actually defined as an entity, and then you get a bunch of annotations to go with it. So everything has a description and a long description. So everything you see in the documentation where it's got a normative description is extracted from here. There may be some supplemental material that we include from elsewhere, but the primary normative description is actually extracted and included in the schema. So you should be able to, if you're trolling the schema, you'll be able to extract it from here, and that should match up to the documentation. And multiple versions of and extensions show up in here. When you actually look at the JSON version, you'll see an unversioned version. Isn't that clear? An unversioned version of the file as well as a versioned version of the file. And when there's multiple versions, they actually get propagated into several versions of the file. In the XML, it's all contained in a single file. In JSON, it ends up with multiple files. That's just pretty much the structure. So the XML is basically all self-contained. The JSON propagates it around. There's quite a few annotations in here that tell you things like, is the storage pool, is this generally read-write? If you have an implementation that you want to constrain further, you're welcome to do that, but you should not go the other direction. There's obviously things like that. A lot of those kinds of rules are already in the Redfish documentation, so we don't bother to put them in the Swordfish documentation unless we're tightening them down. And then you kind of hop into properties. There are some inherited properties that don't, all the properties available don't actually show up in our schema because there are some properties that are just inherited down through the system. So you will see some of those in the documentation, that properties in the documentation that don't show up here in the schema. So it is helpful to refer to the documentation to make sure that you understand the inherited properties. So for here, the storage pool, you see block size bytes, capacity sources. You also see where they come from. So capacity comes from capacity, and also tells you which version of capacity you're referencing. That's very useful information. It's really easy in this variant because nearly everything in Swordfish is going to reference version 1 or version 1.0.0. But as we move forward, those will be very key indicators to watch for. Not all properties are, the way Redfish actually works with properties and even classes is if you don't implement it, if it's not implemented, it's just ignored. We will be putting in the implementer's guide. I didn't say that very well. But if we will put, basically, we'll be putting into the implementer's guide and working with our clients on the models for what is required. There's nothing in the schemas right now that basically says what's a, and I'm going to use air quotes here, what is a required field or what's a required for an implementation. We don't have anything that's called a profile yet. We'll be working on defining that kind of stuff. Because that question's come up and it's a really important question, but there's nothing in the schema specifically that says that. Right now Redfish has very little that's actually required to be implemented, and we need to get to the point that says what's required to be implemented, but we're not there yet. We want the clients to help us drive that. We don't want that to be vendor driven or vendor, the provider side driven. We want that to be client driven. So we're working on a model for that, and we expect to have that come out hopefully within the next few months on a model for how we're going to do that. So we're thinking something along the lines right now where a client would basically come out and say, this is the functionality, these are the properties that we need for to integrate into our environment. So that you can basically go through and look and say, to support Azure Stack, I need this. To support VMware, I need this. And hopefully they're going to be, roughly coincident and not, completely orthogonal. But, something like that, and then we can work on what these profiles are, and then we can also work on a good, solid mechanism we can instrument so that it's clear from an implementation what they support. So that is not something clearly that you'll find in here, which is what's required to support. So going back to what I was trying to say earlier, the way Redfish works and Swordfish works is if a property is not implemented, the assumption from the client side is that it is. I'm still not coming up with a good way to phrase this. Patrick, you want to take a crack at it? What am I trying to say here? If a property is not implemented, the assumption is that
You just don't have to have it present.
it's just not present, right? It's not. It's just if it's not there, it's all right. I'm going to stop because I'm not making. I can't come up with this sentence. So.
In other words, basically, in Redfish, Swordfish, the distinction between saying property is null means we don't know. If this is not present, that's different. That means we don't support it on this instance, or we just don't support it, period.
Yes, thank you. That's what I was trying to say. Badly, very badly. All right. So anyway, so we've covered entity types. We've covered properties. There's a notion in here called navigation properties. These are things like this particular instance is a collection, and there's a notion in here that this also says contains target equal true. This basically means this is basically an array of volumes that exists inside this pool. That's what all of those things together means. There's actually two different types of collections, but I'm not going to go into the distinction between them here because it's ridiculous, so I'm not going to do it. Then there's actually generally also a links section that says these are all these things that are related to it. They don't live inside this entity, but they're all related to it. That's one of those things I was talking about this morning that allows you to troll around and find, here's the chassis that this lives in, or here's some related objects. It's a really great collection at the bottom. I mentioned, I didn't talk about it this morning, and I didn't even show you yet, but there's also the OEM extensions. So you inherit that from resources, or from resource, any place you need to for any implementation, you can add OEM extensions. We have not talked about actions either. There's another element in this system. I don't know how we're doing on time. I haven't seen her pop in. Okay. There's another element called actions in this whole schema, and in addition to normal REST mechanisms, one of the things that Redfish has added is a notion called actions. So if we have something that doesn't map well to traditional REST, put, post, patch stuff, we've added a mechanism that's called actions. It actually, behind the scenes, maps to a post. But what it is it shows up in the system as an action, and shows up as a property called an action. And these are for things like reset. And in the storage world, we've put mapping and masking commands into that. There's not very many of these in the system at all. I think we have 3 maybe that we've added in our entire schema, but it's a really useful construct. So if you happen to see actions in the system anywhere, that's what those are. We also have an OEM extension for actions, but those are also in the system. Okay, so this is the XML schema, and so we shift over. This is what the JSON schema looks like. So I said we have the unversioned thing. I didn't really show you the distinction on the unversioned versus versioned entity types. I'm not sure there was one on the pool, but so you'll see the bulk of the information is actually in the version schema. So everything that was in that version's XML schema is translated into this, and this is just the JSON version. So pretty much, it's whichever one you are more comfortable looking at and working with. Honestly, I'm more comfortable with the XML versions because that's where we're doing all of our work, and we just convert to these. But so here's like that OEM section that gets generated automatically. It's not even in the other document because we don't do it. We don't actually do it. It gets generated for us. So there's that OEM section. Some other stuff that gets generated automatically is a lot of these OData extensions. We've talked about OData a little bit, but haven't talked about it in too much detail. It's just in the mockups. In general, Redfish also does a subset. It's not a full OData client. It's just a subset of OData. And description, name, identifier. These are things that are all, again, defined in that base resource class. So most of them you'll see propagated down through in the schemas, but if they're not in something, they're still there available for use because we inherit them from that primary resource class. Okay, so any questions on the schemas? Uh-huh.
Or puts in there for different, groups of features in that. Does everything have to be supported if you wanted to set them atomically, or when you're failing, is it all or individual? How's that handled? Like if you want to update some of these fields on something or change them, and you're activating something, what's the requirement for making that atomic?
So it depends on the system, or it depends on which things you're trying to change. And so I kind of glossed a little bit over. I said there's 2 kinds of collections. And so it changes a little bit depending on which type of collection you're using. So the reason there's 2 types of collections is because one type of collection assumes you're not changing things very often, and so it uses a different kind of construct, and one assumes you're changing things more often, so it uses the other kind. But it comes back to put, post, patch semantics. But in general, they support that objects support general REST semantics. And so some of the things you'll see, let me go back, well it's here, right? Read only equals true. Let me go back to the XML ones because I can read those better. But you come back to something like a storage pool. Hang on, let me find there was find a collection. Oops, hang on. Yep. It depends on what type of, whether you're doing a put or a patch, right? And so it's going to be, again, it's just going to be typical REST and typical REST semantics. So some of that is also defined in the Redfish specification more than the Swordfish specification. So this schema basically is just going to tell you what you're allowed to do, and the Redfish spec is also going to constrain it back to whether you should be using puts or patches, in which circumstance, and then the implementation is actually going to come. It'll be a little bit up to the implementation to come back and tell you what failed and what didn't. And there are guidelines in the Redfish spec around what kinds of error messages and what level of error messages to report in some circumstances, but not in all cases. So what we are likely to do in the implementation guide, or in the implementer's guide, is put additional recommendations around those. So Patrick, anything else?
Yeah, we tend to not have interrelated properties needed, or non-related properties be, or separate properties be related. So that way, each property isn't an atomic operation. So that way, if I'm patching 3 properties and 2 of them fail, the fact that one word is not breaking in any way for the other 2 failing.
Right.
So and basically the Redfish spec says, here's how to report back that this one succeeded and these 2 failed. What the protocol returns, et cetera, all that stuff's defined. And just basically, it's essentially OData and with a few Redfish extensions. It's the same story. We're doing multiple properties like that. Typically, it's either a post action or it's an actual action.
All right, let's see. So we talked about this a little bit this morning. I didn't actually go through this. Yeah, I don't really think I'll do that either. So what's next? We actually have updated even this since I put these slides together a week and a half ago. So one of the things we're doing is moving really fast on this. I've been reiterating that we've done all of this in 9 months. We expect to continue to move very quickly on this spec. We have tentatively set a v1.1 release target for January. We expect to have a proof of concept around that has 3 components to it. And I'll describe those in a sec. Around the November timeframe, those 3 components are a Swordfish framework, a reference provider with a small set of functionality, and a Swordfish client that matches the functionality in said provider. So the SMI, the Storage Management Initiative, and a couple of our member companies, am I free to name them?
There's a sign on the table out there that lists all the SMI members.
Well, I was just wondering if I'm free to name the companies that are contributing funding to that or not.
I didn't catch that, sorry.
The people that are paying for the POC stuff. I said SMI. Do we? I'll just stop it there. Are basically paying for some accelerated development around a proof of concept that'll be out in the Thanksgiving timeframe. And Hector is helping to program manage all of that. So we have all of that going on, and then in the 1.1 time frame, which we have set in sand as of this week, we are targeting expanding the block and file capabilities by adding event support. There's a basic event mechanism in there. To be clear, there's a basic event mechanism already in the system. What we're talking about doing here is adding thresholding capabilities in a bunch of areas. We have, I believe, 30 issues logged where we want to add a bunch of very storage-specific capabilities around this. We're looking at adding performance metrics. We want to target the implementer's guide. Object storage is actually moved down the list a little bit, and expanded user's guide. So that's the functionality we're targeting for the January timeframe. So it's, again, very aggressive, continuing on with our very aggressive schedule. We also are looking at an errata release against the current spec in next month. That's our current target for that. So we don't think we got it perfect. Shock, I know. And so those are the things that we currently have going. We expect to see, we would like to see more folks starting to get engaged. We'd like to see feedback from folks, let us know what we got right, what we're getting wrong, what we need to change. We'd like to see some reference implementations. I believe we have some companies working on some stuff, but no one has officially announced any Swordfish implementations or reference implementations yet. But we'd like to see some stuff starting to get out there. Other questions? Let's see. Oh, sorry, I need to jump on to pointers. Everyone's got this already. SNIA.org/swordfish. Other ones for the more technical folks in the group, if you want to join the TWG, please join the TWG. Come join us. We have lots of fun. We meet twice a week or so, sometimes more. We have multiple face-to-faces where we get together and do lots of work. And if you're not a member of the TWG, you can always provide feedback directly through the SNIA portal. We are also working on developing, and I talked about again this morning, developing a customer panel. We've already had some people submit requests, so once again, reiterating, if you're interested in this, please let us know. And we also have a customer event next week at the Microsoft Ignite event. If you're going to be at Ignite next week, please let us know. Other questions? More questions? Fewer questions?
As an extension to Redfish and a replacement for IPMI, is this primarily being served up from the BMC with collaboration with the OS, open KCS?
Okay, this is going to be the last question. Thanks. So that's a good question. The expectation is actually that it can be implemented as an out-of-band implementation, but just because we're leveraging Redfish doesn't mean we're leveraging the server infrastructure. We are actually we're implementing, any place storage management can be implemented today, right? So a lot of server storage management is already being implemented out of band, but it can be implemented out of band, it can be implemented in band, it can be implemented as an aggregator, which leverages the BMC implementations for the server components and has another layer that's doing the storage services somewhere else in the system. That should all be completely transparent to the client.